All right, everybody, welcome back. We are heading towards periodic table 8.5C and 6.6A. This TEK is pretty much letting us know, or they want us to know, how to interpret the periodic table. So, do you know how to read the periodic table? So, here are some of the things that you need to know. Go ahead and work with your group and try to answer these questions on your own. Pause the video now. All right, now that you have worked these answers out with your group, we're going to check to see if you got them correct. So let's go to the first one. The atomic number is equal to the number of, we worked this out just yesterday. The atomic number is always equal to the number of protons. Protons is the same number as the atomic number. The atomic mass number is equal to the number of protons plus the neutrons. Both of these subatomic particles are in the nucleus. To get the mass, you just add them up, both protons and neutrons, and you receive your mass number. The horizontal left to right rows of the elements on the periodic table are called periods. Periods go from left to right, and the periods let us know how many energy levels, or we can also call them shells, in an atom of those elements. There are 7 of these rows on the periodic table. So they go from 1, that has 1 shell. Period 2 would have 2 shells. 3 would have 3 shells, and so on and so forth. The vertical columns, which are up and down, are called the groups. Groups or families. There are 18 of these columns on the periodic table. All of these elements in each column have similar chemical properties because they each have the same number of valence electrons. And as we learned previously, valence electrons determine reactivity. So if an element is going to react the same as another element or give the same type of reactivity, they're going to have the same number of valence electrons. So if you look in column 2, all of those elements have the same number of valence electrons, which means they're going to act the same or react the same, and they have the same chemical properties. They're all in need of 6 valence electrons or 6 electrons to fulfill their outer shell to make them happy. All right, let's move on to our next section. It has a periodic table. The directions say on the periodic table below, shade the group of elements that are called the noble gases. And just a reminder, noble gases are the only column or group that does not want to react with anybody else on the periodic table. They're happy, they're stable, they don't need anyone else to make them happy, or they don't need another element to make them happy. Shade all of the elements in period 4 blue. So you're going to look for period 4 and shade that period all the way across blue. You're going to circle 3 elements that are metals. And if you don't remember where the metals are located, check your journal. Also, you're going to draw a triangle around 3 elements that are classified as metalloids. And let's remember that metalloids have properties of both metals and non-metals. Go ahead and pause the video now so you can follow those directions. All right, let's go ahead and start. The first thing we're going to identify is the noble gases, and we're supposed to shade those red. Here are the noble gases that should be shaded red and labeled noble gases. The next thing we were supposed to do is go to period 4 and shade those blue. So if I count down 1, 2, 3, and 4, here is the column that I should be shading blue. The next thing it tells me to circle 3 elements that are classified as metals. Well, anything on the left side of this zigzag line is considered to be metals. So I just circled 3 elements. Simple. All of these elements on the left side of that periodic table are metals, except hydrogen. So if you circled hydrogen, that's a no-no. It is the only one that is not a metal that is on the left side of that periodic table. The next instruction tells us to draw a triangle around 3 elements that are classified as metalloids. And here they go, all touching the zigzag line. All right, let's go ahead and answer the questions at the bottom. Pause the video now and get with your group or partner so that you can answer these questions. All right, so let's check. The first question says identify the metal in period 3 that is more reactive than magnesium. So I'm looking for magnesium, which is Mg, and I'm looking for something that is more reactive and is also in period 3. So let's look 1, 2, 3, and the more reactive metal is sodium. It's more reactive because it has less valence electrons. Okay, less means more and more means less. So the more valence electrons you have, the less reactive you are. You might want to write that down. The less valence electrons you have, the more reactive you are. So since sodium has less, that means it's more reactive. Identify the noble gases with 2 valence electrons. So the noble gases are shaded in red. The only one that has 2 valence electrons but is still considered to be full is helium. Helium is at the very, very top. Even though it does not have 8 to be considered full on its last shell, it completes its shell by only having 2 because of the 2-8-8 rule. The next question says, identify the element in group 17 with 5 energy levels or shells. So let's look at group 17, which is right next to our noble gases. And we're looking for 5 energy levels. Well, what does that tell you to go? I need to go to the 5th period because I'm looking for 5 energy levels. So all I have to do is count down. This will be 1, 2, 3, 4, 5. And that gives us iodine. Identify the element that has more valence electrons than fluorine and fewer valence electrons and fewer energy levels than sodium. So I'm looking for fluorine more. So first let's find fluorine. This is fluorine number 9. And so it says more valence electrons. So if I'm looking for more, I need to go to the right, but fewer energy levels than sodium. So that means our answer is neon. All right, and the last one is identify the metalloid in period 3 with more protons than sodium. That answer is silicon.